Right, hi everybody. Today we are going to be looking at graphing sine and cosine with vertical and horizontal dilations. But actually, we're not going to do cosine, and we're not going to do horizontal dilations because I want to make sure we get the transformations, good, feel strong about the transformations besides trying to squeeze in too much stuff here. So we're just going to focus on that. All right, so hopefully you won't be too mad that we're not getting as much in as I was hoping to. Plus, I already tried to record this once, and it took too long, I think, and it was too quick as well. So let's try this now. All right, so when it comes to graphing, okay, so again, we're going to focus on graphing just plain old sine and see what that looks like. When it comes to graphing trigonometry functions, first of all, you notice we're going to be in radians, okay? Radians will be our preferred unit of measure here, just because it's easy to determine what the reference angles are by just looking at them, basically, and then also because it keeps the scale kind of smaller on the x-axis and stuff like that, okay? 2 pi, right, is like 6 point something, versus if we did degrees, we had to go out to 360 degrees. Now, granted, you can always then change what you count by and stuff like that, but again, radians are the typical measure here. It's a good opportunity for us to practice, being comfortable with those radian measures. You can see over here, I also drew by 30, 60, 90, and 45, 45, 90 triangles using radians, though, to help us evaluate these real quick. So, of course, when we go to evaluate sine of 0, though, 0 is not on our special right triangles, but it is on our unit circle here. Remember, sine of 0 is going to be right there. The y-coordinate, remember, sine is matching to the y-coordinate there. The y-coordinate would also be 0. Okay, at pi over 6, well, sine of pi over 6, there is pi over 6. Sine, remember, is opposite over hypotenuse, so it's 1/2 over 1, or just 1/2. Okay, pi over 2, that also is not on our reference triangles. I mean, it is, but we can't really use them. Pi over 2 is right here. Okay, the y-coordinate there is 1. Okay, 5 pi over 6. So again, this one, it's not on one of our special right triangles, but the reference angle pi over 6 is, so we're going to use that. So sine of pi over 6 is 1/2 over 1, which is 1/2. And we're in, when it's 5 pi over 6 in the unit circle, it's right here, which is in quadrant 2. Remember, in quadrant 2, sine is positive, okay? So we're going to have to we don't have to worry about, making this a negative 1/2 right here. All right, at pi would be right here on the unit circle, which means we're out to this point right there. Y-coordinate there is 0. 7 pi over 6, again, the reference angle is pi over 6, and so it's going to be 1/2. But now for 7 pi over 6, that means we are right here on the unit circle, which is a negative y-coordinate. So we're going to put a negative 1/2. 3 pi over 2 is right here on the unit circle. Y-coordinate there, negative 1. Okay, 11 pi over 6, that's right here on the unit circle. Y-coordinate there, negative 1/2. And then finally, 2 pi is 0. Okay, because again, 2 pi, I guess, is right around to here. The y-coordinate at that point is 0. Excuse me. So, what are these going to look like? Well, let's plot these points. So, you can see here our highest y value is 1. Our lowest, y value is not 0. It's negative 1. So, we need to make sure we go up to a positive 1 on the y-axis and a negative 1 on the y-axis. So, at 0, 0, we have our point. Pi over 6 there is 1/2. Pi over 2 is 1. 5 pi over 6 is 1/2. Pi is 0. 7 pi over 6 is negative 1/2, 3 pi over 2 is negative 1, 11 pi over 6 is negative 1/2, and then 2 pi is 0. So when I go and connect these dots, you'll see what kind of shape we get. It's a wave, right? This is going to continue on like so forever, and same thing in this direction as well. Okay, so the domain then will be negative infinity to infinity. There's no problem x values. You can plug in whatever x value we want. The y values, though, we are limited here. What's the lowest y value you see? It's negative 1, right? What's the highest y value we see? It's 1, and we do get there, right? And that kind of comes from our unit circle right here, right? The highest y value on the unit circle is 1. The lowest y value in the unit circle there is negative 1. Amplitude is a new vocabulary term. It is the height of the wave from the center. You maybe have seen that before in a physics class or something like that. So the height of the wave from the center is just 1, right? Amplitude should always be positive. Always is positive because it's a measurement. It's a height. Okay, the period, okay, kind of refers to different things. So it can refer to two different aspect. It can refer to an interval, you know, where the wave starts and stops kind of thing. Or not where it starts and stops, but where like a one full wave, you know, kind of the starting point of one wave to the end point of that wave. Okay, so in this case, right, we started at 0 and we went out to 2 pi. On the other hand, you could also talk about period as the width of one wave, how wide a wave is. So if we start at 0 and we go to 2 pi, well, that means the width is 2 pi. Sometimes we'll refer to that as the period length, which is the width. So again, that would be 2 pi. We'll talk about stretching or shrinking this in the next lesson. We're going to focus on just amplitude and this vertical stretching and shrinking right here. So your transformations for sine, you know, very, again, typical kind of stuff we've seen before. A vertically stretches or shrinks, reflects over the x-axis if A is negative. Here's this horizontal stretch or shrink we're going to see there, the B value there in, you know, in front, in the sine, but in multiplied with x and the h. So that's going to be a horizontal stretch or shrink by 1 over B. We'll worry about that again in the next lesson. Minus h is going to shift things left and right, and then plus k is going to shift things up and down, okay, just like we're used to seeing there, right? So let's see what happens when we put in a 2 in front of that sign. I'm going to do one more of these big full tables like this, but then I'll show you like a more efficient kind of table to make than all these like individual points. So, you know, again, I'll just repeat this just for sine. I'll just repeat all these values here that we had from, you know, the previous table. We already kind of evaluated these, so I'm not going to go back and redo all of them. I mean, kind of discuss all of them, I should say. Okay, like that, and then we're going to 2 times sine x, just means we're going to double, excuse me, all these angles, so like so. Let's go ahead and graph it. So I will graph the 2 sine of x here in red, because that's going to be your final answer, and then I'll show you what the, you know, I'll show that compared to the regular sine of x as well, which I'll put in green or something like that. Okay, so just plot these points here. Okay, so there's our 2 sine of x. Whoops. Mess that up here. Let me see if I can get that to look better. There we go. Okay, something like that. And of course it'll go on. Right, you can kind of indicate with some arrows there. And then in green, I'll put our little sine graph right here too. So we'd be 1/2 at pi over 6, 1 at pi over 2, 1/2 at 5 pi over 6, 0 at pi, 1/2 at 7 pi over 6, or negative 1/2 at 7 pi over 6, negative 1 at 3 pi over 2, negative 1/2 at 11 pi over 6, and back to 0. So this is what the sine of x graph looks like in comparison. Oops. Kind of see there that stretch, right? The zeros are all the same, right? Because 2 times 0 is still 0. But when you have your peak here at 1, it now doubles to be the 2 there, right? And when you peak your valley there at -1, it, you know, goes down to -2 instead. Okay, so there's, you know, you kind of see that stretch, right? But the width of the wave still stays the same. I will do one more here, and this one we'll do with -1/2 sine of x. Now, what I'm going to, when I go to fill out my table here, though, I'm going to pick slightly different values. Well, not different, but fewer values for x, okay? When it comes to graphing here, there's only really, for one full wave, I only really much come up with 5 points. You'll notice up here we did more than 5, right? And I'll show you what 5 points I would like you to do. Okay, so, we're going to have you put the starting point and the stopping point of the wave right here. So in this case, right, for a plain old sine of x graph, right, the period is between 0 and 2 pi. So we'll start at 0 and end at 2 pi. Then I want you to find the halfway point. And so what's halfway between 0 and 2 pi? Well, that's pi, right? Just 0 plus 2 pi is 2 pi, divide by 2 pi. And then I want you to also find the quarter points. You know, what happens in between here and here as well. So what's halfway between 0 and pi? Well, that's easy. It's pi over 2. Halfway between pi and 2 pi, well, if you add those two together, that's 3 pi, and then divide by 2, you get 3 pi over 2. Okay, so these quarter points here will give us all the points we really need to come up with the graph. It'll give us all our zeros and all our peaks and valleys too. okay, to get the graph. If you want to do more points, you're welcome to, but this would be a good, like, efficient way to do things. Okay, so sine of 0, 0 times 1/2, negative 1/2, sorry, will still be 0. Pi over 2, sine of pi over 2 is 1. 1 times negative 1/2 is negative 1/2. Okay, sine of pi is 0. 0 times negative 1/2 is 0 again. Sine of 3 pi over 2 is going to be negative 1 times negative 1/2 gives us positive 1/2. And then sine of 2 pi is 0 times negative 1/2 will still be 0. So when I go to graph this here, and again, I'll do it in red. Okay, 0 will still be 0. At pi over 2 will be at negative 1/2, so right there. At pi, we'll be back at 0. 3 pi over 2 will be a positive 1/2, and 2 pi will be back at 0. And so if I connect these dots here, oof. Okay. I need to, like, pick up my pen in between so that way when I make an error I can, there we go, something like that. I'm not a big fan of that last one. Let's see if I can fix that. There we go. Okay, so you can see what's happened here. Well, we had a shrink, right, because of that 1/2, and then it also reflected over the x-axis as well. You can tell the reflection because normally our sine goes up and then up, right? But here it goes down, then up, then down, okay? So it reflected, right? And so let me just, and for comparison's sake, I'll go ahead and draw in the normal graph of sine as well here for us, just in green. So you can kind of see that reflection and the shrink. Okay, and so there you go. This is what I would like you guys to graph. Okay, I'm gonna give you 2 functions to graph. I'm not going to give you out of the book because the book only gives 1 with just an amplitude change. So I'm going to give you 2 with an amplitude change just on our own here. So don't worry about going to the book and stuff. But anyway, thanks guys. I hope that makes some sense. If you have any questions, please again feel free to message me and have a good day.